Okay, so we're just going to take a moment in this next video here to talk about still division, but we're going to talk about dividing when remainders are involved. So far in the previous video, we looked at these really nice divisions where we were able to very easily split these numbers into equal bits. Now, this isn't always going to be the case. We're actually, at certain points, going to face a division where we can't get this in equal bits. And when we arrive at this, we need to think about how to what actually happens when we hit this roadblock. So we looked at these really nice numbers. Now I'm going to give you a couple of examples to show you what we mean by the remainder. Now, also, let me quickly define this. So a remainder is the amount left over when dividing into equal parts or equal groups. A number into equal groups. Okay, cool. So this just tells us that we're not always going to divide really nicely. So when we come across this, we have to still consider some equal groups that we have, but we have to also think about, well, how much is left over after we've split this up equally? So I'm going to give you an example here. I'm going to say, what is 7 divided by 2? So I'm going to draw my 7 little coins. This is just a way I like to think of division. I like to draw these little coins. You can draw whatever you'd like, whatever helps you do this. Now, I'm dividing 7 by 2. So you can almost always see here, well, I'm going to, as soon as I have an odd number here, dividing by 2, I'm going to encounter some difficulties, right? Because even numbers, at least in this case, this even number of 2 doesn't really go into 7 nicely. But what I'm going to do to approach it, I'm still going to say, okay, well, let's think about starting to split this number 7 into 2 groups. Now, I can see here that I've got 4 on the top, 3 on the bottom. Why don't I just draw a line through here, just separating top from bottom? Now, you can hopefully see here that I can see a couple of equal groups. Well, I can see this one, and I can see this one, but I have this weird one over here on its own. So I can say that my 7 divided by 2 is going to be 3 because we can split it up into 2 even groups of 3. So we can write equals 3, but there is a remainder of 1. There's 1 remaining here. We couldn't split this into equal groups without taking the remainder and, say, placing it over here. Because once we shift this across, cool, we have a pretty even split here, right? And there is a remaining number that's stopping us from getting it really bang on dividing perfectly. So when we do this division, we have to consider this remaining number. So we can say 3 and we can say remainder. And how many numbers are remaining? Well, there is a remainder of 1. There's only one of these little circles that's left. So that is how we can think about dividing with a remainder. Now let's try one more question. Let's see what happens when we do 50 divided by 9. Okay, so I said before that dividing has very close ties with multiplying. So in order to find this, I'll give you a hint. There will be a remainder here, but we just want to find what it is. So thinking about our 9 times tables, for example, we can say that 9 multiplies by a certain amount of groups to get me somewhere close to 50, but not exactly that. If you think of your 9 times tables, all right, we have 9 times 1 equals 9, 9 times 2 equals 18, 9 times 3, and a lot of this comes down to you remembering your times tables, which is going to be pretty important anytime, call it kind of all across school. So I would encourage you, if you don't know them so far, to maybe have a go at them. So we have here, let's do 2 more. So we can see we're getting closer to 50. 9 times 5 gives me 45. But when I do 9 times 6, I get, 54. So my number 50 is somewhere between these two here. So if I divide my numbers here, I'm going to get some kind of remainder, right? Now, the smallest number to do this kind of thing, we want to find the smallest, the highest possible number that this will be when we multiply. So the 5, for example, that gives me 45. That's the closest number to 50 without getting bigger than 50. So we can say that when we split this up into 5 possible groups, let me just wipe all this out. We know 9 times 5 gives me 45. Let me shift that up here a bit. Let's write this here just so we know where we're at. So 9 goes into 45 5 times. Whoops. So this is going to equal 5, but there's going to be a remainder here. And that remainder, well, how many numbers do I still have to fill to get from here? Whoops. To get from here to here? Well, I need 5. So this is going to be 5 with a remainder of 5. Now, I encourage all of you to you can even draw this up. Draw your 50 pieces. Let me do it now, actually. I'll do this very quickly. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50. Okay, so I've drawn my 50 out, and I can show here that when I divide this into nine equal bits, well, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 equal bits here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 equal groups, all containing 5 in them. So that's this number here, but I have a remaining 5 here. So this here, whoops, let's draw that a bit nicer. This here is going to be my remainder. So this is the remaining bit after I've divided this into 9 equal groups. After I've divided this number 50 into 9 equal groups. And this here is my remainder of 5. So that's how we'd work with remainders. And in the next video, we're going to look at some mental strategies for doing divisions in our head and without using a calculator. So I'll see you there, and thanks so much for watching.